Google section for obvious reasons. So first step, you select your workpiece, and then you specify your blank or your raw material size. So you can do that with just as you model the part, you can model a block yourself, and especially if it's a complex raw material, that would be one of the only ways. You can offset from the part, which means it takes all the part surfaces and it offsets them in all directions by a certain amount. Or the one that I use most often for simple things like this is a bounding block, where you can specify offsets per axis, so in each direction. So if this is your part, you're offsetting your raw material. You're telling your raw material is 100,000 this way, this way, this way, that way, and up off the top. So once you've specified the workpiece, then I like to specify the work coordinate that I use for that operation. And you can have, with the workpiece, you can have multiple operations. You can work on the top, you can work on the bottom. You just have to flip the axis and your tool axis. But your tool axis will automatically be related to the coordinate you use. So in this case, I said operation 1, and you can add any coordinate system. And in this case, it's in the top left corner at the top of the raw material. So if you look, this is where that coordinate is. If you bring up your workpiece again, you look at the blank, the work coordinate I picked is in the top corner of your blank. And it follows what machines usually are, X, Y, and Z. And what's important is that on the machine, obviously your block is not square, so you have to line up your long edge with the X-axis. Otherwise, if you do it the other way around, you're going to get a weird result. You're not going to make a part out of the block. Your block will be like this. So it's important to take your machine coordinate and put it correctly in your CAM software, and then double check that when you set up your workpiece, it matches what you defined. So we've picked our workpiece, we've picked our coordinate system, and now you can create the operation and then go through each option and then play around and see what each option generates. I'll show you 2 examples. So one, we talked about adaptive milling. So what adaptive milling does is it tries and keep a constant engagement. That's why it spirals out. So it enters the part with the arc and a helix with a certain ramp angle. And you'll find that when you go into specify your approach or your non-cutting moves, all ramp angles are set at 15 degrees. Please change that to 3 degrees. Don't use 15 degrees. It's way too much for these types of cutters. Usually cutters can anything from 1 to 5 degrees. That's a good range to use, and then maybe 3 degrees is a good conservative number. So in adaptive milling, We pick the coordinate system. Because we're working with this workpiece, the part is already predefined. And then you can also specify the boundaries of what you're cutting. You're telling it that even though I have raw material on the outside of the part, I want to cut in this area. And don't ask me why I pick outside or inside. For me, inside is inside the pocket and outside is outside, but in this case, outside is inside. So sometimes it says there's no material to cut, just flip this from side trim from inside to outside or the other way around. And then when you select the curve, a nice trick when you select the bounding curve or the trim boundary. In this case, we want a curve, and then you pick an edge, and then instead of picking each individual edge along a part or a part with multiple pockets, you can just say tangent curves, and it'll pick all the edges that are tangent with that first one. Okay, so we've done the geometry. We picked our tool. In this case, I said maybe a 5/8 end mill that I defined myself. When you're actually posting out a part, you have to pick the right tool number and register. And then I made the tool axis in line with the Z plus Z axis of my coordinate system. So I've done that, and now I go into my method. It's adaptive milling. My maximum distance I picked as 10% of the cutter diameter. You can pick anything you want. The less it is, maybe the less productive you are, because you're taking very light radial cuts. And most tools can take at least 10% of their diameter. The bigger this number is, the fewer tool paths you have. So, okay, I'll show you what
That maximum distance was the radial depth of cut?
That's the radial depth.
Okay.
But then if you're doing like facing, then it would be the axial. You have to pay attention because it's specific to what you're doing. So this is with 60 thou radial step over. So this is how it gets into the material. And then it automatically does this. You don't have to tell it. So the biggest possible part, and then it starts treating each area as individually. And now let's say instead of 60, we say 1/4 inch. See, now it's a much bigger radial step over. Okay. So under cutting parameters, we want to climb mill. When you're doing multiple levels, you can tell it to do the depth first or radially first. And then I've left some stock on the part. for finishing. And then for the non-cutting moves, in this case, I wanted to engage the workpiece with the helix, which is the equivalent of drilling a hole. You could use two tools. You could use a drill to drill a hole. Let's say you have 100 of these pockets. Maybe you don't want the end mill to do all the ramping. Maybe you already want to give it access, so you use a drill to drill 100 holes, and then you now have access to each pocket, and then the end mill just has to go into each hole and then start opening the pocket. You have a question?
For stock leftover, is there any requirement on that? I used to be 0.02 inches, but is there any other requirement?
No, it's, I would say no, you just have to be aware of your final part geometry. So sometimes we leave more stock on very thin, tall walls to keep them rigid for finishing. But 20 thou stock is fine. Maybe don't leave 5 thou because you're roughing, and then usually both on the machine and roughing tools are not as accurate as finishing tools, so sometimes you may not have any stock left over to clean up, but yeah, anywhere between 20 to 50 thou for finishing is good. The same applies for floors, like webs. Sometimes you want to leave floors, especially on large pockets, thicker, and start in the middle and work your way to the stiffeners. That way you're leaving some stock, so the material is a little bit more rigid, and you're also starting at the most flexible point while there's still stock in that pocket, and you're working your way out. If you start on the outside and work your way in, you've removed all the support from that floor and you've left it all in the middle. But for these types of parts, it's fine. So here you can set your approach in the closed area, and also your retract, along with many other types of options. And then for feeds and speeds, I mentioned that you can back calculate each one, so you can fill in any single one of these. You fill in the surface speed, the feed per tooth, as long as you define the correct number of flutes in your tool, your spindle speed and your cut speed, and then if you change any one of these, it should back calculate the chip load, for example. I don't know if it did. So I changed it from 50 to 20, and then I clicked on the calculator and it changed the chip load. It's kind of gimmicky. When you go into this much trouble to program a part, you usually know what your feeds and speeds are, but it's there if you need it. And same for SFM and RPM. And then, like I mentioned before, you can set different, for example, rapid. Maybe you don't want to go, you tell the machine to rapid at G0, which is the rapid mode of the machine. Maybe you want to, every rapid move, you want it to feed. I don't know why, but there's some unique instances where you want to do that. Let's say you're in a corner and you're slicing that corner, and you have lots of little tool paths. Maybe you don't want to come down, slice, come up, wrap it over, come down, slice, come up. Maybe you just want to feed and then stay at that level. So your approach is a feed, therefore you can stay on the material. So you're always feeding, and then it's a nicer motion for the cutting tool and the machine. But you wouldn't want to do that with rapid because you don't want to wrap it across the part. So there's benefits of each, but usually I set this to rapid. And then different types of speed rates, and then also your units. Then I did another type instead of adaptive milling. This is using more trochoidal pocketing. It's trying to do what adaptive milling does. Maybe I'll slow it down. This is trochoidal pocketing, but it's more like level by level. Instead of using this, you could also use zigzag or whatever. Please explore the software. So where adaptive milling, you can take light radial cuts and you can go full depth. This one you can take maybe heavier radial cuts and do it in multiple Z levels. And you see here, instead of using a helix to approach the material, I'm using a linear ramp. Okay, let's take a break. I have your first assignment here, if you want to make it up.